Okay, ladies and gentlemen, so Law of Sines video part 2. As you can see here, we have 3 different triangles, actually. At first glance, it looks like there's only 2, but we have triangle STU, we have triangle SUR, and we also have the outermost triangle, which is triangle STR. So we can use any combinations of those 3 triangles using the Law of Sines. Now, how do I know that? Well, after we're done labeling these angle measures in here, we're going to notice that there are no right angles, okay? Typically, if we have right angles or a right triangle, we would use, our traditional SOHCAHTOA. But in this case, we do not have right angles. So let's get right into it. So what I'm going to say here is on the left triangle, over here, triangle STU, we have 37 degrees and 65 degrees, which leaves 78 degrees left over. All right, I'm just subtracting both of those from 180 degrees. Now, these 2 angles together form a linear pair. Therefore, this angle here, and this is weird, the diagram just not really letting me label so clearly, but that's going to leave 102 degrees in here, right? So we have 70 degrees here, 102 here. As a matter of fact, 61 degrees is this angle here. So now we have 102 and 61 in this triangle. So what I'm going to do is subtract both of those from 180, and that's going to leave us with just 17 degrees, right? So we have 17 degrees up here. We now have all 6 angles labeled in our triangle. So now let's back up here and let's try to figure out our goal. Our goal is to find the length of TU. So there we go. Now here's the tricky part. Guys, we mentioned that straight across from the side should be the lowercase version of that. But here's the weird part, right? We could actually use S in 3 different scenarios. So what I'm going to do is I'm just going to use, I'm going to pick variables that I'd like. All right, I don't want to use S because I'm not sure which side across from S I'm going to use. So let's take a look. Where is a side length that they gave us? All right, so here's 14. So here's my approach, and there are many approaches. Some people, might try to find the entire bottom here and then try to subtract pieces. Here's my approach. What I'm going to try to do is I'm going to try to use the outermost triangle and find side ST. Now, so I don't confuse myself, I'm actually going to draw a diagram of the outermost triangle STR. Right? Now they told me SR is 14, and I'm just grabbing that information from over here. Now I want my angle measures, right? So I'm going to have 65 degrees, I'm going to have 61 degrees, and then up top there, what do we have? 37 plus 17. So we're going to have another third angle up top there of 54 degrees, okay? 17 plus 37. So now here's what I'm going to do. In this case, I'm going to use X. I'm just going to pick some different variables here, right? So guys, I want to use the Law of Sines. I know that 65 has 14 across from it, and I have 61 across from the side I want. Now I also want to notice that 65 is across from 14, so I'm thinking across from 61 should be a little less than 14, just trying to predict my answer. So what I'm going to do is I'm going to set up a Law of Sines proportion right here. What I'm going to have here is the sine of 65 degrees is to 14, right? Sine of 65 has 14 straight across from it, the same way that the sine of 61 is to what I need. All right, so once again, we have one variable and we have the other 3 values plugged in. All right, I'm going to cross multiply. Now, after doing this numerous times in class, guys, I'm just going to skip to the next step, and hopefully you can follow along. I'm going to have x sine 65 degrees equals 14 sine 61 degrees. I'm going to get x alone by dividing by the sine of 65 degrees. And guys, I want to see this step right here, okay? 14 sine 61 divided by the sine of 65 degrees. At this point in time, I'm going to go to my calculator. I'm going to type in my values. I'm getting approximately 13.51, which makes sense, right? We said we tried to predict that it was going to be a little less than 14, so that makes sense. Now, what I'm going to also do is I'm going to put 13.51 over here, all right, as side ST. Now, I am almost finished, but this is going to be a 2-parter. So now my goal here is, we said, was to find TU. So now I'm going to only use this sliver over here, triangle, STU. Now I have a side length, right? I have 13.51 over there. So now I'm going to redraw my picture just so we're not confused again. I like to do this just so I know what sides I'm using and what angles are in play. So I'm going to draw my triangle, and it's just the triangle on the left. So that's going to be STU. Those were angle measures of 37, 65, and 78. Okay, now I also want to add the fact that I know that this is 13.51 now, right? We just wrote and solved a law of sines proportion to find that. So now I'm going to finish up here. I'm going to use the variable y. Okay, now remember, that's our goal, to find the length of TU. So I'm just going to use the variable y, which is down here. Now let me zoom in and focus my attention on the next law of sines equation. My law of sines equation is going to start off with the sine of 78 is to 13.51, right? The same way that the sine of, right, 37 is to y. All right, now I'm going to focus my attention on solving this proportion. Okay, I skipped ahead a little bit just for the sake of time, but my proportion was set. I'm going to cross multiply to get my second line. And then what I'm going to do is divide by the sine of 78 to get my fraction. From there, it's all calculator work. After typing in the calculator, I'm getting approximately 8.31. All right, and that's going to be units because they didn't give us anything, and we have concluded this question. All right, guys, so just remember, we don't have right triangles, so we're using the law of sines, and it's a two-parter. All right, because we got to use lengths from one to get another side, and then use that side for our second law of sines equation.